Hey guys, and welcome back to Maths with Cats. So today we're going to be going over geometric series for AQA A-Level Maths. So the first thing we're going to go over is the formula for the sum of a geometric series. So if you think about it, as we know from the sequences video, these would be all the terms, and we want it to go up to this term, because that would be the nth term. That's not very useful for finding a formula. So let's try lots of the sum of n. And I know that might seem a bit silly. Well, this by itself actually doesn't seem that useful either. But if we do the sum of n minus r lots of the sum of n, you end up with, well, a minus, there's no term, it's just a, so that's that. AR minus AR, A squared minus A squared, AR cubed minus AR cubed, AR to the n minus 1 minus AR to the n minus 1 minus AR to the n. So, altogether, you end up with A minus AR to the n. But that isn't the sum of n, that's the sum of n minus r lots of the sum of n. So, what you can do is take out a factor of 1 minus r from the left-hand side and 1 minus r to the n from the right-hand side. And then, if you divide by 1 minus r, you're left with the sum of n. So this is our formula. I believe it's in the formula book, so you don't need to worry about memorising it, but that's the formula you need to know. Okay, so here's an example. There is a 64 square chessboard with a 1p piece on the first square, 2p on the second square, 4p on the third, 8p on the fourth, and so on. Calculate how much money is on the board. Now, we did see a similar question in the sequences video when we did the geometric example there, but it wasn't the how much money is on the board for that one. It's a different question. Okay, so from the question, we know the first term is 1 and r is 2. So the nth term, u of n, equals 1 lot of 2 to the n minus 1. And s of 64 must be 1 lot of 1 minus 2 to 64 over 1 minus 2. We didn't actually need the nth term in this case, but I gave it just in case. And that is equal to this. That is a massive number in standard form. Okay, so we left it in that form. You could convert it and say, and basically you could round up, round down, and if you want to keep it in pence, you could put it into pounds and pence. Really up to you. Okay, examples. If A equals 20 and R equals 1/5, find the first 5 terms of the geometric sequence and the 20th term. So, as you know, u of n equals AR to the n minus 1. We know that u1 is 20. So, u2 is going to be 20 lots of 1/5, which is 4. u3 is going to be 20 lots of 1/5 squared, which is going to be 4/5. u4 is going to be 20 lots of 1/5 cubed, which is going to be 4 over 25. u to the 5 is going to be 20 lots of 1/5 to the 4, which is 4 over 125. And u20 is going to be 20 lots of 1/5 to the 19, which is again a massive number in standard form. Didn't ask for it in the question, but what you can see from this is that the sequence is tending towards 0, but it'll never reach 0. So if you wanted to do it graphically, the line 0 would be the asymptote. Sum to infinity. So there's some things you need to consider with this. So if the modulus of r is less than 1, then as n tends to infinity, a lots, basically the s of n, is going to tend to a over 1 minus r. This gets really big, then you end up with 1 minus a really big number, which is going to be a really small number. So that kind of cancels this out to give it just a. And 1 minus r. If s of infinity is equal to a, so s of infinity is equal to a over 1 minus r, where our modulus of r is less than 1. If the modulus of r is less than 1, then r is between minus 1 and 1. Sorry, my laptop's just, there we go. Okay, so if a equals 2 and r equals a half, find the sum to infinity of the geometric series. Well, s of infinity is equal to 2 over 1 minus a half, which is 2 over a half, which is 4. This means the sequence will get infinitely close to 4, but never reach 4, i.e. graphically, there's an asymptote at 4. Examples. My laptop's being slow again. I don't know why it's being slow today, so I just have to wait for it. I'm still doing the cat thing in the corner. I think it looks a lot better and it makes everything flow a bit better. I'm also, what was I going to say? Still keep putting feedback in the comments if you've got any, because I find that useful. Anyway, it's coming out. If a equals 2 and r equals 2, find sum to infinity of the geometric series. Now, since the modulus of r that's supposed to be a 1, more than 1, we can not use the equation we know. In this case, as n tends to infinity, the sum to infinity would also tend to infinity, which means it can't be worked out. It's as simple as that. Okay, final example. On a child's first birthday, £3,000 is invested into an account with a fixed compound interest rate of 4% a year. Interest is paid in every year on the child's birthday. What will the account be worth on the child's 7th birthday? In this case, A equals 3,000 and R equals 1.04. So U of M would be equal to 3,000 lots of 1.04 to the n minus 1. This means U7 is equal to 3,000 lots of 1.04 to the 6th, which is this big number. So to the nearest penny, it will be £3,795.96. When will the account have doubled in value? So we want to find where 6,000 is equal to 3,000 lots of 1.04 to the n minus 1. So divide by the 3,000, so 2 equals 1.04 to the n minus 1. Now we're going to use logs. We've not used this yet in this series. You probably haven't used it at this point in your course if you're up to the point of this video, if that makes sense. But you will go over it. So it probably won't make much sense for now, but this is how you do it. So the number at the bottom, the base number, becomes the base of the log. So it goes under the equal sign. So it becomes log base 1.04 of 2 is equal to n minus 1. And you add the 1, and you end up with 1 plus log base 1.04 of 2 is equal to m. And if you type that in the calculator, you get 18.67298769. But because the interest is paid every year on the child's birthday, it would only be on the 19th birthday when it is worth the more. Okay, so that's the end of the video, guys. I hope you liked it. I hope you enjoyed it and found it useful. Sorry about the little pause in the middle there when my laptop crashed. If you have any feedback, put it in the comments below. Yeah, if you liked it, then subscribe, like the video, comment, let me know if you found it useful, and I will see you in a future video, hopefully. Bye bye!